Alright, welcome to chapter 4, section 1. This is graphing on the coordinate plane. This is quite easy. It's simply, if you have a coordinate system, which is labeled with an x-axis, a y-axis, it will look like this. Let's see if I can draw it real quick. Bam. And bam. Let me zoom out a little bit so you can see it. Alright. So, if I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and 4. Okay. So, this here is called the x-axis. This here is called the y-axis. Now, where the point in which the x-axis and the y-axis meet is called the origin. And the origin is labeled 0, 0. Okay? So, when you're going this way, these are positive. When you're going this way, these are negative. When you're going up, that is positive. And when you're going down, that is negative. All right? So, that is basically the basis of the graphing aspect. Now, in terms of a coordinate, you label the coordinate as x, y with parentheses around the end, okay? The x, it can be positive or negative. The y can be positive or negative. And you always graph with the x first, okay? So if we have our coordinate right here, and we want to graph 3, 6, you would go over to the right 3 and up 1, 2, 3, 4, 5, 6, and guess what? You make a point right there, label it 3, 6, just like that. All right. If you have a negative, so we'll say this is 1, 2, 3, 4, 1, 2, 3, 4, 5. You would have negative 2, 1. That means the x is negative, the y is positive. We're going to go to the left 2, so we're going to go here, and then up 1, which is right here, and you have this point right here, okay? Let's do another example. If we have 8, no, I don't have an 8. Let's say I have negative 3, negative 4. This means you go to the you go 3 to the left and you go 4 down. You're at this point right here. Okay. You check yourself. Will basically go over all of this, give you different examples. What they will ask you to do is, let's say you have your coordinate system like this, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So they'll give you this point here, call it A. This point here, call it B. This point here, call it C, and a point here, calling it D. They want you to find the what these points are, basically. So let's do that real quick. You have 1 to the left, 2, 3, 4, 5. These are negative 5, by the way. 1, 2, 3. So negative 5, 3. Don't forget the parentheses. This one up here is going B. That's A, okay? So that's A. B is 1, 2. I put it in the middle, kind of, sort of, so it's going to be 3. It's not really in the middle. I don't know. Whatever. So you're 3 to the right, and you go up 2. So this is going to be 3, 2. All right? Here's another one. Let's say we have... Let me do a different color. Let's use red-ish. 1, 2, 3, 4. 1, 2, 3, 4. So this one is going to be negative 4, negative 4. it is essential that you put the negative signs, otherwise you will end up at a different point. For example, if you put -4, +4, you're going to be at this exact same spot, but only up here, okay? We don't want that. If we're going to find D, we're going to go over 1, 2, 3, 4, and down 1, 2, 3. There you go. And this is going to be +4, -3. All right, this is my favorite section because we're starting to get into kind of like upper level math, but still in Algebra 1, okay? So this, we're going to be talking about relations and functions. Basically, they will be giving you an X and Y system, and you have to say point, there's a points, right? And you have to say, is it a function or not? Is there a relationship or not? When you put in this specific X, do you get this specific Y? Basically, that's what this is saying, okay? So, if I have, let's say, oh, and I have to tell you what exactly a relation, function, domain, blah, 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 all those are, okay? A relation is a set of ordered pairs, the X and the Y. As I explained earlier, the X, comma, Y, this is the relation. This is a relation, okay? Gotcha. So, next, we have a domain. A domain is a fancy word for, it looks like this, domain, fancy word for X, okay? That's all it is. The domain is talking about the X side, okay? Then we have the range. And the range is talking about all the Y's, okay? So, and then a function, and you'll be talking about functions until you decide you don't want to do math anymore. Function is basically if you have in the most basic of definitions, a function is an X and Y, and you plug in a certain X and you get a certain Y. You plug in a certain X, you get a certain Y. You plug in a certain X, you get a certain Y, okay? So, a function is basically, the way they explain it to like younger people, a function, let's say you have this, right? Let's say you have a factory, okay? And in the factory you have you have something that goes into the factory and then it comes out something else, right? So like for example, Henry Ford create Ford cars, right? So back in the day, he had, what was it, a conveyor belt, I think, or whatever it was, right? So on the conveyor belt going in, let's draw it. If I have our factory, and this is out, and this is in, the function is in here, and this is our in, okay? So the in, something goes in, and then it comes out something else, but it's a specific relation that these two have. This would be, the ins would be known as our x's, and our outs would become our y's, okay? You plug the x value into the function, and then you get your y value, okay? So that's what a function and a relation are, okay? Let's give some examples. So, find the domain. I'm doing an example now. Find the domain and range of each relation. Is each relation a function? Okay. So in order to determine what a function is, there's two ways to do it. If you have a graph, and if you have a table of values. And if you don't know what table of values is, I will show you. So, two ways, okay? A graph, like such. Let's say we have a function that looks like this, right? Alright, cool. So, function looks like this, and in order to tell if this is a function, it's called the vertical line test. Now, the vertical line test is simple because all you have to do is draw a straight line down in many places as you like. And if it crosses this straight line more than once, that's not a function. If it crosses the straight line more than once, it is not a function. If it only crosses once, then it is a function. Case in point, I'll have this graph right here. If it looks like this is what's called a parabola. You'll learn this later. If I draw a straight line, it only crosses once right here. If I do it again, it only crosses once right here. Do it again, it only crosses once right here. Do it again, only crosses once right here. If I have another graph and it looks like this, if I draw a straight line, this is not a function because it crosses here and it crosses here. This is not a function. Why? Because it crosses here and here. Another function. Not a function, excuse me. This is called the vertical line test. And what the vertical line test shows is if it is a function or not, okay? Let's see. If I have a graph that looks like this, no, I don't like that one. If it's a oval like this, or an ellipse, depending on your terminology, draw a straight line. This is not a function. It crosses here and here. This is not a function. It crosses here and here. Still not a function. It crosses here and here. It needs to only cross once in order for it to be a function. Now, if you don't have a graph listed and you only have a table of values, this is how you do it. So, a table of values looks like this. If I have an x and a y, let's say I have 3, 4, 5, 6, and 8, 11, 14, 19, all right? So, there's some relationship between these numbers. We just don't know what it is, okay? So, whatever it is, we can either A, graph it like we did with these and try the vertical line test, or A, we can do the method 2, which method 2 is if you plug in this and you get only one answer, there you go, that is a function. 1x, 1y, 1x, 1y, 1x, 1y. This is a function. Now maybe that wasn't clear, so I'll give you a counter example to show you what the opposite would look like. If I have an x and a y system, and I have a 3 and a 4, 3 and 8, a 4, why did I do it out of order? A 3, a 5, a 7, and a 9, and if I do 3, I get 6, excuse me, let me try this one. If I do 1, 2, 3, 4, and another 3, okay? If I have 6, 7, 8, 9, 10, the flaw in this is, to prove it's not a function, is if you have the exact same x with a different y. So you see that these 3's are the exact same, right? But these y's are different. So that is not a function, okay? That's basically what this says. Let's do another example. We have an x, we have a y, we have a -3, a -5, a 6, a 7, a -3, a 4, -2, and a 2, okay? So the problem is right here. You have a -3 with a 4 and a -3 with a -5. Which is it? You can't have this and this, okay? If the x's are the same, the y's have to be the same as well. You can't have one x giving you one y and one x giving you one y, a different y, excuse me. Okay, that should be quite clear. So to test a certain given amount of points, you can either A, use this method, or B, you can use the vertical line test, which we learned over here, okay? Cool. All right, so chapter 4-3 is called function rules, tables, and graphs, okay? So a function rule is an equation that describes a function, okay? So for example, if I have y equals x plus 6, the way you graph this would be, actually I think we get to graphing later. Oh, okay, let me use a different example then. So if we have x and y, we have our table of values. We have a 1, a 2, and a 3. We have 7, 10, 13, okay? So, this table of values is put together by the function y equals 3x plus 4. Let me try that again. 4, okay? In which the x is a input, or we learned earlier, which is called a domain, and this is our output. And you can test it if you put 1 into our x. 1 times 3 gives you 3. 3 plus 4 is 7. Bam. 2 times 3 is 6. 6 plus 4 is 10. Bam. 3 times 3 is 9. 9 plus 4 is 13. There you go. Okay. So, let's see. If I have... Come on now. Okay. This is a example of a function, okay? And this right here is called an equation, okay? So, a function is notated, or you can use the word notation. Basically, a function is... What is notation? Notation is a fancy word for how you write something, okay? So, they basically make math very difficult for people because they don't explain the notation. You have a whole bunch of different phrases equals y squared plus pi to the fourth, and then you have theta and a triangle and all this. So you have all this, and you're like, oh my god, I don't want to do math, right? So you have all this and you're confused, right? But it's not even that bad, because what I'm about to explain is going to make it all right. So step by step, we have the notation for a function which what looks like this. F of x is a function, okay? Now, the way we can rewrite it is, think of it this way. You see our y equals 3x plus 4 up here? Think of it as this. Y is the exact same thing as f of x. So, in the future, if you get confused by an f of x, just put a y there, and you'll feel better. I do it all the time. If I see a notation I don't like, I just replace it with like a blank spot, like a square. So if I have like sine theta, cosine squared theta, or some trig stuff like this, I'm just going to replace it with a box because I don't want to look at that. It's messy to my eyes, right? So it's not pretty. It's not appealing looking like that. So I'm going to change the f of x to a y, okay? Sorry I threw all that trig at you. You're probably confused at the moment. But anyways, so you have y equals f of x. That is the exact same thing. So I can write f of x equals 3x plus 4. And now you have the exact same thing. It's only rewritten because this changed, okay? So let's go down. That's called function notation, okay? And it's pronounced this f, you see f parenthesis x close parenthesis, this is pronounced, come on now, this is f of x. That's all you say, f of x. That's it. And then you're going to have something that's going to confuse you again. This is going to be g of x. G of x. Then you're going to have something else that's probably going to look like this, which is just going to be h of x. You feel me? Okay, cool. Moving on. These are all notations for functions, okay? Just wanted to let you know that. Okay, so now let's keep going. Evaluating function rule, application, graphing functions. Alright, the way you check to see if something is a function, you should know this. You'd use the vertical line test. Okay, the table of values method might not always work, because then you'll have to think like, okay, what's the point for this? And if they don't give you a point, you're going to be a little confused. But if they just give you a graph, you'll be all right. Okay. All right. So if we have, let's do an example from the check yourself real quick, and I'm moving on. So if I have h of x equals a fourth of x, like I said, we're just going to rewrite it. So now we're going to have y equals 1/4 x. Now, this is a graph that looks like this. You have your graph, and it's going to be going up because this is a positive slope. We'll get in a slope later, but it's going up like this. Use the vertical line test. Bam, bam, bam. It only crosses at one spot each time. Once, twice, 3 times. That is a function. And it's asking, model each rule with a table of values and a graph. So, what you're going to do is all you have to do is make a table of values. What I would always suggest is using the table of values. You want to use -2, -1, 0, 1, and 2. Okay? I'll do this one for you. So if we have y equaling a fourth of x, you're going to have y equals a fourth times 2, okay? We know that a fourth times 2, I'm sorry, that's a -2, isn't it? That's a -2. I'll explain later, or excuse me, -2 goes right here. So a fourth times -2, we're going to have, we know because we know how to multiply fractions, right? I hope. A fourth times -2, come on now, is going to just look like this, -2 over 4. We know we can divide by 2 on both the top and bottom. -2 divided by a +2 is going to be -1. A 4 divided by 2 is going to be 2, okay? So what we have here is -1/2. That is our final answer, -1 over 2. Or you can write it as -0.5. That's basically going to be the middle of your line, okay? And by the middle of the line, I mean like this. Look at our graph. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. Basically, we're going to go the graph, the point, once, twice, and then a half. Is it positive or negative? I think it's negative. Yes, it's negative. So, -2, and then -1/2 would be the halfway between. So therefore, it's going to be -2, -1/2, which is right here. Okay, let's do the next one. We know that -1 times a fourth is just going to make it -1/4, which is also -0.25. Let's go back. So if we go -1, which is right here, we're going to go down half. A fourth is half. Excuse me. A fourth is half of 1 over 2. Now, we know that this is a whole, this is a half, this right here is a fourth, okay? So we're going to go over to the left, 1, and then down a fourth, okay? Next one. We know that 0 times anything is just going to be 0, so it's going to put a 0 there, okay? That's a point at the origin. So what we're going to do is put a point at the origin. The origin, like I said before, is the point in which they cross. Now we're going to do 1 times a fourth, which is, remember, in our function over, where is it, right here? So a fourth times 1 is just going to be 1 over 4, okay? That's going to be the exact same thing as this one. By this one, I mean this one, but only positive now. So now we're going to go over 1 up a fourth. Remember, this is half of a half. So now we're going over 1 up a fourth. We're right here. And then we're going to do another one. 2 times a fourth gives us a half. Remember, because 2 over 1, excuse me. We know that 2 times a fourth is going to just give us a half, like so, because the 2 and the 4 cancel, making it 2 over 4 divided by 2, and we get 1 over 2, okay? So this is going to be a half, and then we go over here, we go over 2, and a half. Alrighty. Then you draw a straight line to mark the points you just got. Let's see if I can do it. It looks like that. Let me change the color of this. Change the color. I want green. Why not green? All right. It's not perfect, but it's pretty close. That is our function, our graph. Okay. And then we want to see if it's a function. Like I said before, Bam, 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 bam. Vertical line test, it passes each time. Okay? There you go. All right, I'm gonna go fast on this one. Chapter 4-4 is writing a function rule, okay? Writing a function rule is quite simple. All you're doing is you're going to look at the x's and we're going to look at the y's, find what's common about them. That is going to become our relation, okay? Excuse me, not our relation. That's going to become our, excuse me, our slope, okay? So I'll show you how to do all that, okay? So writing a rule from a table. So remember again, if we have our factory, right? This is our factory or our function. We know that something goes in and something goes out. This is our output. This is our input. So whatever goes in is going to come out something else, and it better be consistent. We know this, right? So we can't have a 3 go in and we get a 5, and then we get a 3, another 3 go in and we get a 1. Okay, it don't work that way. Okay, so if we have a 2, we're going to get a 6. If you put another 2, we better get another 6. If you put another 2, we should not get a 3. Okay, that is not a function. That is the point here. So writing a function rule. Basically, we're going to be given the in and the out, and when we're giving this and this, we are allowed, or excuse me, we will be able to find this right here. Okay, this is going to be called a function rule. Okay, so let's examine this. If I have x and f of x, remember this is notation, right? So this is the exact same thing as x and y. So just letting you know, x and f of x. You can use whichever one you're comfortable with. If you like f of x because it looks cool, then use f of x. If you like x and y because it looks simpler, use y. Okay. So, anyways, I'm gonna use f of x. So, we're going to have x be 1, 2, 3, and 4. We're going to have 5, 6, 7, and 8. Okay. So, excuse me. So, let's see. Well, we know that, let's see. I'm plugging my iPad from the wall. We know that, obviously we can see that whatever you're doing to whatever the x is, we're adding 4 to it, okay? So you added 4 and you got 5. You added 4, you got 6. You added 4, you got 7. You added 4, you got 8, okay? So what we're going to do is we're going to rewrite it in a equation. So now we have our f of x and we have an x, okay? So f of x equals x, what? Plus 4, right? So f of x equals x plus 4. That is our function rule. Quite easy, right? Okay, let's do another one. If I have x and f of x, and I have 1 and a 3 and a 6 and a 9, and this is going to be 1 and a 9 and a 36 and a 81, well, we should know that from pre-algebra that these all seem to be multiplied by themselves. We know that if we multiply 3 times 3, that's going to give us 9. If we multiply 6 times 6, it's going to give us 36. If we multiply 9 times 9, it's going to give us 81. Same thing with the 1. If you multiply 1 times 1, you're going to get 1, right? So what we know is you can square something. We learned about exponents, right? So exponents basically say the degree in which, if this is something squared, we're multiplying this box times this box, right? So therefore, this is the exact same thing as this, right? It's a bad arrow. Hold on. This here is the exact same thing as that. So if we can rewrite it as, well, first of all, we know that it's f of x, right? and we know it's going to equal because we're talking about an equation, and we have an x, right? So we know it's going to be x, but we know what's happening to the x. It's being multiplied by itself, so we can either rewrite it as x squared or x times x. But we know that if we put x times x, we better put some parentheses, otherwise it's not going to make sense. Or excuse me, otherwise later it'll be more confusing if we just put x times x and then you have like 3s and 6s and 8s or whatever other constants or variables we have later in the equation, okay? So it better either look like f of x equaling x squared, like this, or like this. Either one is the correct answer, but if the teacher specifically wants you to simplify, you better go with this one, okay? Cool. Let's do another one. So, let's see. Let's do an example. So, from the check yourself. Match each table with its rule. That's too easy. So, when it comes to the match each table with its rule, basically what you should do is just plug in the x's in the table of values to each course, or to each 1, 2, or 3, respectively, and see what you get. It looks real easy. Let's do write a function rule for each table. Let's do a hard one. Let's do number 9, okay? So number 9 says we have x and y. You have -8, you have 64, you have -4, you have 16, you have 0, you have 0, you have 4, you have... Oh, this is easy. Oh, never mind. We'll do it anyway. All right. So basically, if you noticed before I did, you're basically multiplying all these by themselves. You multiply 0 times 0, you get 0. You multiply 4 times 4, you get 16. If you multiply 8 times 8, you get 64. And it's the exact same with its opposites, right? We know this. So the function rule is going to be the same like in the earlier example. You're going to have y equaling x squared, basically. That's quite simple. Quite simple rule. That'll come up kind of often. When you get to Algebra 2, I'll teach you that this is called a parabola. Okay? Just write it in your notes, and we'll get to it later in life, okay? One more before I go to the next section. If I have x, let's see, x and y, and I'd have 1, 2, 3, 4, and I have -3, -6, -9, and -12. Well, this is kind of simple. All you have to do is just notice that whatever we did with the x, we kind of just, how do I explain it? Well, let's see. We have a 2 and we have a 6. Don't worry about the negative signs, because obviously it's changing because we have our y and we have an x equals something x, right? So, come on now. Why did that happen? Oh, Lord. I'll just draw it again. X and y. We have 1, 2, 3, 4. -3, -6, -9, -12. Well, obviously, in order for a positive to become a negative, we have to multiply by a negative, or divide it by a negative, right? It doesn't look like we're dividing because the next numbers are bigger than the first numbers, okay? So that's just an observation real quick. So if we have y over here, we have an equal sign, we have x. So that's our first step. Write it out like that. Next step, we have y equals, we know that you have to multiply by a negative. So there's going to be a negative, and then we're going to put a box because we don't know what's in there yet, and then we're going to have x, okay? Next step, we're going to have y equals, oh, that's ugly, equals negative, let's see. Well, it looks like all we did was we multiplied it by 3, because we're disregarding the negatives now, because it doesn't matter, because we already wrote it in our equation. We multiplied 3 times 1, we got 3. 3 times 2, we got 6. 3 times 3, we got 9. 4 times 3, we got 12. Okay, so it looks like we're just multiplying by negative, I can't draw 3's, negative 3x, and that is your equation rule. Simple enough? All right, this is chapter 4-5. Now, this is the point in which I start teaching with my own kind of methods rather than the going by the book, because going by the book is kind of boring. If you were just to go by the book, if you were to go by the book, you could just go by the book and you don't need me, right? So For example, this chapter is called direct variation, and when I first looked, I was like, what the heck is direct variation? I don't know what that is, right? So then I looked at it and I was like, oh, that's just what I learned back then, right? So forget what it's called. This is 4-5, and I'm going to teach you just how to do it so you'll be set, okay? So basically, this is just isolating the variable, basically. That's basically what this is, okay? So they'll give you something ugly that looks like this, 8x plus 9y equals 10, and you need to get y by itself. And I'll show you how to do that, okay? So we have 8x plus 9y equals 10. Let's see. First step, we want to get y by itself. So we have an 8x and a 9y and a 10. So we're going to subtract 8x to over here. And then we know this goes away. We have 9y equaling, you can either write it as negative 8x plus 10. Actually, write it exactly just like that, okay? 9y equals negative 8x plus 10. And then we're going to divide by 9 by the entire thing, right? And now we have y equals negative 8x plus 10 over 9. Now, that's ugly. We don't like it that way. So what we're going to do is rewrite it as y equals negative 8x. And we can break this up because this logic right here. For example, if I have a fourth plus, no, not a fourth. Let's do a fifth. If I have a fifth plus 2/5, come on now. Hold on. Okay, so here we go. So if I have a fifth plus 2/5, I know that this is the exact same thing as 1, I can't draw. 1 plus 2 over 5, right? So with that same logic, I can do the exact same thing. If 1 plus 2 over 5 equals 1 over 5 plus 2 over 5, well, these two are the exact same thing. Well, I'm just going to go back over here, and because we know that, I can split these up. So now it's negative 8 over 9 times x plus, actually what I'm going to do is I'm going to do it like this. Negative 8x over 9 plus 10 over 9, okay? Don't worry about trying to simplify this 10 over 9. When you're doing my work, you don't have to simplify it, but when you're doing it with your teacher, whatever they want you to do it their way, okay? But what I'm saying is you don't have to worry about simplifying this to become 1 and 1 over 9, okay? Because that looks ugly. I don't like that notation, okay? So either one of these is the correct answer. I'm not a stickler. I could care less, but excuse me, I could specifically care less about how you write it. But either way, you'll get the correct answer. Because if you plug the x in, you'll get the correct answer. Cool beans? Cool beans. Let's do another example. If I have 5 this one, negative 12x equaling 6y. This is very easy. All you have to do is divide by 6 on both sides. Now we have y on one side equaling negative 12 divided by 6. A negative divided by positive gives you a negative. 12 divided by 6 gives you a 2, and then you just bring the x along for the ride. Bam. There's your another answer. Next answer. One more before I go. Okay, this one's easy. If you have negative x equaling 10y, divide by negative 1 on both sides. I'm sorry, not by negative 1. You're going to divide by 10 because we want to get the y by itself. We're going to divide by 10. We have y equaling negative x over 10. There you go.
I guess not.
All right, we're at chapter 4-6, and I had to look at this one because this one made less sense than the other one, because when they explain it to you, they want you to be confused, apparently. Okay, so basically, this is called inverse variation, which is the opposite from direct variation. Now, I'm going to tell you what these terms mean, and then I'm going to tell you how to actually make sense of it, okay? So we have direct variation and inverse variation. And the way math is set up is they want you to They basically, what they did was, let's take easy concepts and use big words that people don't understand what they mean because they're very complex and what the heck, to explain the easy concept, okay? So, quite simple. Direct, excuse me, is that what it says? Direct? Yeah, direct variation is this here. It is when you have, where is it at? Here it is. Direct variation. That's when you have in your equation, right? So if you had like y equals 3x, this here, because they don't want to teach you what slope is yet, 3 is going to be called k. Don't ask why it's called k. They decided that it's going to be called k. And for this time given being, I will be using k as well. So k is the number in front of the x, basically, okay? So y equals 8x, this is k, when we're talking about direct variation, okay? Now, sometimes we don't know what k is, okay? So, excuse me, sometimes. All the times, we typically don't know what k is because k is a crazy term that they came up with, okay? Oh, and by the way, k cannot equal 0. Just wanted to let you know that. Let me write this down so you can take it in your notes. Y equals 5x. This is k, okay? All right, and then we have inverse variation, where they'll give you, so if you have y equals k and x, right? They will give you a y, let's call it 5, and they won't give you k, but they'll give you a 6. So therefore, what you have to do, and see if I can explain this correctly. Okay. So this right here is an example of direct variation. An example of inverse variation is this, is when you don't have k, you have your x equaling 5 and your y equaling 6. So what I want you to do is disregard this example, even though you know what a direct variation is. Let me take that back. We know that, blah, forget that part. This part, yes. This part, no. So y equals 6 and x equals 3, okay? Oh, well, x equals 5. I like 3 better. So if y equals 6 and x equals 3, what you have to do is just multiply those together to get k, and k equals 6 times 3. Therefore, k equals 18, okay? That's all you have to do for inverse variation. That's all you have to do for 4-6. If they give you x, multiply it, and excuse me, if they give you x and they give you y, multiply it, to multiply them together, and you get k. That's all you have to do, okay? That's the first part. Exam 2. Each pair of points is a graph, blah, 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 blah. So basically what you have to do is, okay, so in the check yourself problems 10 through 21, it looks complicated, but it's actually quite easy, because all you have to do is, for example, let's do number 10. We know that it says 6, 12, and 9, y. 6 times 12 gives us 72, and we know, basically this is what you do, okay? You simply multiply these two together and divide it by whatever number they give you. So 72 divided by, I'm going to write it out for you. So 6 times 12, trust me, that's a 12, and then divide it by 9. 6 times 12 gives you 72, divided by 9 gives you 8. That is your answer. 8 goes right in there, okay? If you have 3, 5, and then you have 1, x. 3 times 5 gives you 15, divided by 1, you get 15. 15 is x. And I'll do one more example. Let's do a hard one. If we have 500 times, not 500 times, 525, parenthesis, and then we have 4, x. All you have to do is multiply 500 times 25. You should get 12,500 divided by 4, and I believe that gives you, what is that? Carry the 3,125, I want to say? Yeah, 3,125. That'll give you your x. Bam.
Okay, 4-7. Chapter 4-7 is quite also simple. I'd say every chapter is simple, but anyways, chapter 4-7 is easy because it's just inductive and deductive reasoning. And basically, the pattern, it's all it is recognizing patterns and then applying them, right? So all you have to do is know whether you're adding or multiplying or dividing or subtracting or whatever you have to do over and over and over again, okay? So inductive reasoning is making conclusions based on patterns that you observe. A conclusion you reach by inductive reasoning is also known as a conjecture, okay? And then, let's get to an example because words are boring. Okay, so if I have the pattern, 2, I don't like that pen. 2, 5, 8, 11. Now, what we can notice is there is some type of special difference between these two, and these two, right? So if you noticed, to get from 2 to 5, you add 3. To get from 5 to 8, you add 3. To get from 8 to 11, you add 3. So with this, we know that the next pattern, or excuse me, what the pattern is to add 3. So with this being said, we know that it'll keep going on and on and on and on just by adding 3 and 3 and adding 3, okay? So basically, you can use inductive reasoning to find what the next two numbers are, being that 11 plus 3 is 14, and 14 plus 3 is 17. So when the instructions say find the next two numbers, find the pattern, and apply the pattern to find the next two numbers. Quite simple. Okay? If we have 2, 4, 8, 16, we know that, well, first let's think. Are we adding? If you add 2 to this, you get 4, but if you add 2 to this, you don't get 8. What if we multiply by 2? If you multiply by 2, you get 4. If you multiply by 2, you get 8. If you multiply by 2 again, you get 16. So yes, multiplying works, okay? So the pattern is to multiply the original number by 2, by 2, by 2, by 2, by 2. So find the next two numbers in the sequence. 16 times 2 gives you 32, and 32 times 2 gives you 64. Perfect. Let's do another one. Okay, let's see. Okay, here we go. If we have this one seems difficult. 3, 1, negative 3, negative 3, negative 1, negative 3. So what this is simply subtraction. You subtract 2, you get 1. You subtract 2, you get negative 1. Subtract 2 again, you get negative 3. You find the next two in the sequence. That's quite simple. Negative 3 minus 2 will give you negative 5. Negative 5 minus 2 will give you negative 7. There you go. What's another one? 3, 3.3, 3.63, and the next one is 3.993. 3.993. Alrighty. Okay, so this one is quite simple as well. All you have to notice is what the pattern is, of course. So, is it adding, multiplying, subtracting, or dividing? At this point, we know that the numbers are steadily increasing, so we know it's either going to be adding or multiplying, okay? So, we do know, let's see, what do we know? Okay, so what I'm going to do is I'm going to take this one, divide it by this one, and just see if I can find a common ratio, okay? So 3.3 divided by 3 just gives you 1.1, and 3 times 1.1 gives you 3.3. 3.3 times 1.1 gives us 3.63, okay. So this is the pattern. You multiply by 1.1, and you keep doing this to find the next two numbers of the sequence. That's quite easy. Multiply 3.993 by 1.1, and you should get 4.3923, and then multiply that times 1.1, and we get 4.83153. There's another 3 at the end. There you go. So these are the two numbers of the sequence right here. Sorry, that was a bad circle.